Hi guys, welcome to another video. In today's video, I'm going to show you how to set up a production-ready emitter cluster on top of Kubernetes, which is running on top of Microsoft Azure. It's going to be actually quite simple if you've seen other Kubernetes setups, but if you haven't, no worries, I'm going to show you. And what's interesting is that, as I mentioned, we're going to set up a production-ready cluster, so we're going to have a persistent storage, SSD-backed storage, and a load balancer as well. In one of the previous video, I set up a cluster of Kubernetes using a Kubernetes service EKS on Azure, and here I have it emitter demo cluster running. It has a total of 4 cores. It actually has 2 nodes. As you can see here, I have 2 standard nodes. Nothing fancy. I have a console running as well, tunneling, so I can go here and look at the cluster. I have no pods currently. I have nothing running. Now, without further ado, let's actually go and run. What you need to do first is you need to clone this particular or download this particular set of configurations. And there's a few configurations, one for broker, one's for DNS and load balancer, and forget about this one. I'm gonna update it quite soon. So I have a specific configuration for Azure. Now, it's not that different from others, except that it actually uses managed premium storage class, which is included in Azure. So one thing you want to do is when you open broker YAML, you want to add this license, right? You can do it by just retrieving the just starting the emitter. So if you have a meter Go, for example, you just do this and it will generate a new license. You can use this license and keep, of course, a license secret key. Now, once you have configured kubectl, if you do cluster info, it will let you know which master you're running. Okay, we're actually on East US Azure Kubernetes. And what we can do is we now can configure a service, kubectl, apply, and we do service DNS. So this one is actually a DNS name, well, a service which just lets you set up a DNS name. And what it does is for the brokers, so they can talk to each other on port 4000 in this case, we have this DNS name, right? So they can discover other brokers through this. And that's what the service is for. And then you want to do is apply a load balancer service. The load balancer service is pretty simple. It's actually sets up an external load balancer on port 80 and 443. So, and actually targets port 8080 on the brokers. So this is for your MQTT, for your publish subscribe traffic, and that's for your secure SSL or TLS traffic as well, right? So what it does is just set up a load balancer so you can talk to brokers through a load balancer instead of talking to them directly. And once you did this, now you can actually as well set up a broker, right? And this will take a while. So we'll actually spin a stateful set, and if you're going to look at here, this is a stateful set. It represents a set of pods with consistent identifiers. So you have broker 0 and broker 1 and broker 2. In our case, we have 2 replicas, so we'll have broker 0 and broker 1. We have this affinity, which is really important because you don't actually want to set up brokers, all of them on the same machine. That will actually compromise your high availability, right? Because then if one node goes down, all your brokers suddenly are down. You don't want that. So this is anti-affinity policy, meaning if there's already a broker set up on a particular virtual machine, please don't set up another broker on this machine. Few configurations. So you have license, you have a cluster seed. As I mentioned previously, this is DNS name, and you advertise a port 4000 to other brokers. We configure SSD storage, which is really important if you want to have persistent storage. And in this case, we mount a data volume, which is broker volume, and the broker volume is a managed premium storage class, which is provided by Azure itself. Okay. So now what we can do is we can look at our pods. Right, we kubectl get pods, and you can see that one of the brokers is running, the other is created. Let's look at the logs. So if you do kubectl logs, broker 0, we can see that node was created, few connections, and license was configured as well. So now if we look at logs of broker number 1, which is just happened to be created, so created successfully, and it also joined a peer, right? So we have a reliable cluster created and they talk to each other, right? If we go back to broker 0, we also had a peer created, right? So that is pretty much it. Now how do you access this? Well, let's look at our services. So if you do kubectl get services, you'll get all the services, and then we'll see that we have a load balancer and we have our cluster IP with none, which is just for DNS. So the external IP is the one you want. So now if we open this, you see it's bad request, but if we open a keygen page, now we're actually getting the key generation page directly from one of the two brokers through a load balancer, and you can talk to this IP in your client through your brokers, and you have a production ready cluster. Anyway, that's it for this video. Thank you for your attention, and please subscribe, click the like button, and let me know if you want any particular topics to be discussed. Thank you.